Okay, I'm going to show you how to graph rational functions. This assignment is on page 231, and I have an example here of a rational function that I'm going to graph. Now, the graph of a rational function can approach without intersecting certain lines called asymptotes. And these lines are really important to find when you're doing a graph. Now, to find the asymptotes, one thing that's interesting to do is look at what happens when the fraction becomes undefined. And in this fraction, if the bottom is 0, the fraction becomes undefined. So if I take the bottom, x minus 3, and set it equal to 0 and solve that, I get x equals 3. Well, when you do that, it really means that x is not equal to 3 when you're trying to find the graph of this equation. Because at 3, you get an undefined situation, but every place else, you can get points to plot on a graph. So that's the key point to look at, and then we want to look at both sides of what happens to the graph as it approaches 3. So we want to do a table for x less than 3 and another table for x greater than 3. So, and then you're just going to figure out some points by plugging in some numbers. And then make a table of values to see what happens. And as you do that, if I start taking x greater than 3, I might look at 4, 5, 6. And if I plug those in, I get the value 4, 2.5, 2. If I try 7, I get 1.75. If I try 8, I get 1.8, and so on. And then I wonder, well, what happens when I try really, really big numbers? Okay, so let's continue this chart over here, f of x. And what happens when I try to go to the extremes here? So what happens if I tried like 18? And I look at my table and I get 1.2. Well, what happens if I try 100? And I get 1.03. So that's kind of interesting to look at. So I have to do a graph of this function, and I need to plot these points. So if I start plotting points, if I go over 4, up 4, I get that point there. If I go over 5, I go up to 2.5. If I go over 6, 1, 2, 3, 4, 5. Oh, these are off a little bit here. If I go over, let's do that again. Over 4. 1, 2, 3, 4. Up 4. 1, 2, 3, 4. All right, if I go over 5, up 2.5. If I go over 6, 1, 2, 3, 4, 5, 6, I go up 2. If I go over 8, 6, 7, 8, I go up to 1.8. And I see that I'm getting a curve, not a straight line, right? And I know x can't be 3, right? Because that makes the fraction undefined. So at 3, I put a dashed line, which is called an asymptote. Because my graph is not going to hit that line. And then I can connect these dots, and then I put an arrow not touching that dashed line, which is an asymptote, but approaching it as much as I can. And then, if I went all the way over to 100, I still get only 1.03. So I notice that this graph has a second asymptote. It looks like it's approaching the line 1. So I put another asymptote there at y equals 1. And then let's graph some of the less than 3 numbers and see what happens there. So let's, at 2, I get negative 2. I can plot these points at 1. I get negative 0.5. At 0, I get 0. At negative 1, I get 0.25. At negative 2, I get 0.4. Now let's try some more of the negative ones, f of x. Let's try like an extreme. What happens if I do negative 100? And again, I can look this up using my calculator, and I get 0.97. So again, some interesting stuff is happening. So at 2, I get negative 2. So at 2, I'm down at negative 2. At 1, I'm down at negative 0.5. Okay. At 0, whoops, wait a minute. At 1, where was I here? I'm going to just do these over again. So at 2, I'm down at negative 2. I thought I plotted that wrong. At 1, I'm down at 0.5. At 0, I'm at 0. At negative 1, I'm at 0.25. At negative 2, I'm at 0.4. Now again, you can see the curve that's happening, right? And so the curve approaches this line here, and if I connect the dots, it approaches this line here. Now, another thing you can do, right, at, let's see, at negative 2, at 2, I go down to negative 2. I could figure out what happens at 2.5, and I'll find out that it again goes down further and it approaches that line. So what line is that approaching, right? It's approaching the asymptote, which said is x equals 3. And then it's also approaching this asymptote here, which is y equals 1. So this graph has two asymptotes. And again, use your graphing calculator and try and figure out what's going on. Some important things. Look at the table. Change how the graph looks. Remember, on your graphing calculator, and I'll show you mine here if I turn this on, and I typed in that equation. If I look at the graph, and I don't know if you can see this or not, but there's a line on that graph that's not part of the plotted points. The graphing calculator, what happens is it's plotting all of these points, and then when it thinks it gets to the lowest point here, it jumps up to the highest point, and it sort of forgets to lift up its pencil, so to speak, and you get that line there, which is the asymptote. But if you go to your y equal, and if you change to get your graph to just plot points, just plot points without drawing the line, you can get to see just the dots on the graph. So investigate with your graphing calculator different ways to look at the graph. Another thing you can do is you can go to your window and set your window. I'm going to change mine to -5 and then 5 and see how that changes the graph. And let's change that. All right, so if I changed on my x-axis -5 to 5, you kind of get a better view of what happens on the graphing calculator. And if I change the window on the y-axis, I can see what happens a little bit more there. So don't be afraid to change your window. And remember, to get back to the original, you can go to the zoom button and go down to what's called zoom standard. And that puts it back on a 10 by 10 grid, which is the one I started with. But it shows that line there, which isn't part of the graph. It's called an asymptote. It does not show the y equal 1 asymptote, though. You need to figure those out, the asymptotes, by investigating what happens on your table and remembering to try, the extreme big values on both of them. And you also can try some of the decimals between the asymptote on both sides, too, to see what happens. I graphed at 2, I got this value, -2. What happens at 2.5, 2.9? And you'll get some very interesting numbers down in here to confirm that your graph is correct. So good luck with this assignment. I think it's a fun graphing assignment. It really helps you learn about your graphing calculator. So that's it for now.